we're asked how many terms are there in the sequence below, and here we have that the first term is negative 15, the second term is negative 11, negative 7, negative 3, and then all the way to 77. So one of the things to notice here is that this appears to be as though it is an arithmetic sequence because there's a common difference of 4 between terms. So that is, to get the second term from the first term, we're going to add 4, and add 4. So in the previous video, we came up with a formula for calculating the nth term of an arithmetic sequence. We have that t sub n, the nth term, is equal to the first term a plus n minus 1 times d. So we know that the nth term is going to be the first term plus n minus 1 times d. So here we're asked how many terms are in the sequence. We know that the nth term here is 77. So we have that 77 is equal to the first term, which is negative 15, plus n minus 1 times the common difference, which is positive 4. So times 4. So to figure out what the common difference is, we're going to first off add 15 to both sides of this equation, and if we do that, we get that that n minus 1 times 4 n minus 1 times 4 is equal to, let's see, 77 plus 15, which is 92. And if we divide both sides by 4, we get that n minus 1 is equal to 92 divided by 4, which is 23. Solving this equation gives us that n is equal to 24, because we just added 1 to both sides of the equation to isolate for n. So therefore, there are 24 terms in the sequence. Okay, so problem 4, it says, given the 5th term in an arithmetic sequence is 55 and the 20th term is negative 21, determine an explicit formula for the nth term. So let's first think about the information that we're given here. So we're given the term number, given the 5th term is in an arithmetic sequence, so we're told that the sequence is arithmetic as well. So therefore we can assume that there's a common difference. So the 5th term is 55 and the 20th term is negative 21. And then it wants us to just determine a general formula. So we know that the general formula for the nth term is equal to, it is equivalent to a plus n minus 1 times d. Okay, so we have to figure out what a is, and we have to figure out what d is to find a formula for the nth term. So let's think about this. Well, let's think about if the 5th term is 55 and the 20th term is negative 21, we know that we would have added the common difference. Let's see here. We would have added the common difference 15 times to 55 to get negative 21. So the common difference, or we should say that 15 times the common difference is going to be equal to negative 21 minus 55. Okay? So, in order to find what the common difference is, the common difference is going to be equivalent to negative 76 over 15. And let's see here. can we simplify this? So 15 is divisible by 5 and 3. To check if 76 is divisible by 3, we can use the divisibility by 3 test. And negative 76 will only be divisible by 3 if its digits add up to a number that's divisible by 3. 7 plus 6 is 13, which is not divisible by 3. And it's also not divisible by 5 either. So this fraction is not reducible. So what we have now is that t sub n is equal to a plus n minus 1 times negative 76 over 15. The next thing we have to do is we have to solve for the first term. So there's a couple of different ways to do this. We could just subtract the common difference four times from the fifth term. So that's one way to do it. Or we could also just plug in what the fifth term is, and then we could solve algebraically for a. And let's just do that because it's so we'll say substitute 55 for t sub n and 5 for n. And if we do that, we get that t sub 5 is equal to 55, which is equal to a plus 5 minus 1 times negative 76 over 15. Okay, so let's see what we've got here. So we have that we're going to have a minus 76 times 4 over 15. So 76 times 4 is 304. So we have a minus 304 over 15. And that's equal to 55. And thus a, which is just equal to 55 plus 304 over 15. So 304 over 15 plus 55 is equal to 1,129 over 15. So we have that a is equivalent to 1,129 over 15. So therefore, the explicit formula, and it's kind of a messy formula. So therefore, the explicit formula is t sub n is equal to 1,129 over 15 plus n minus 1 times the common difference, which is negative 76 over 15. And we should probably simplify this as well. We could write this as t sub n is equal to negative 76 over 15 n plus, let's see here, we've got 76 times negative 76 over 15 times negative 1, which is positive 76 over 15, plus 1129. So we could just do 1129 plus 76, which gives us 1205. So 1,205. And now we can check for the divisibility. We know that 1,205 is divisible by 5 because they both have digits that end in 5. So if we divide this by 5, we get that it's 241 over 3. So this should be 241 over 3. So that is the formula for the nth term of that sequence.